Hey everyone, welcome to the Tektite R NATS kit build tutorial. So before we even start building, the first thing you're going to want to do is focus the laser pointer. So this kit comes with these focusable laser pointers that are labeled to be class 3R, and this is a slightly legal label. And you can essentially twist this knob to just the focus. And before we assemble the kit, we're going to want to have it focused. So this is how you do it. First, grab the battery pack and just plug it into the main PCB, like so. Then use the JST PH connector to plug it into the laser port. Now we have a go, stop, and laser button. So when you press this laser button, the laser should turn on. As you can see, it's turned on. So basically you can twist this knob to focus it. Once it's focused, it should look like this. It should be a nice and precise dot. So before putting this together, you're going to want to solder on these wires, okay? So essentially a JST connector 5-pin comes with this. And the way it works is this will go into the PCB. Now on the PCB, you'll see this side is labeled PWM. So the corresponding PWM pin should be blue. So the blue pin on the motor corresponds to the PWM pin on the PCB. So when you line this up, you'll see that the very far pin is black. So if you trace this down, you'll see that I soldered black to blue. Now from there on, everything is sequential. For example, the next pin down corresponds to the next pin in the motor, and so on. I'll also make a diagram of it on the blog, but make sure you solder on the connector before putting the vehicle together. All right, so now that we're done focusing the laser, let's get started with building. There are 3 types of screws in this kit. There are these M3x6 screws, and yours will come with a hex head, but mine are Phillips head. There are these countersink screws, and you can tell because they essentially have a chamfer on the screw head. And finally, there are 2 of these grub set screws that will be used to attach the wheel hubs. So we're going to start with this. This 3D printed piece right here is the motor mount. And essentially, you want the motors to be like this, with the wires not interfering with each other. So you actually want it so that your wires are lined up like this, where this is the front, so you have space for your laser pointer here. There are these holes right here that will go into these holes in the motor mount block. As you can see by these chamfered holes, this is meant for countersink screws. So use the H2.0 screwdriver and screw it in. So one thing to note about this is that this is a metal screw screwing into a metal gearbox. So what happens when the motor vibrates is that the screws will actually work themselves out, which is why I'd recommend you grab some blue Loctite and apply to these screws before transporting them, because during transportation, this vehicle will undergo a lot of vibrations and you don't want these screws coming out. So I'll put in the other 4 screws. So now both motors are installed. Now let's do the wheel hubs. So this is the wheel hub. The set screw will go in here, which will go up against the D shaft. So just line those up and push it in. That goes in. Now grab a set screw and tighten it on. This is on. Also make sure you push this in all the way. There should be just a really tiny gap to leave some clearance, but it shouldn't be anything bigger than this. Now we're going to assemble the wheel on top of this. So put on the wheel, unless it's a very tight fit, and then on this side, you're going to want to grab the wheel hub and grab a tiny little magnet and press fit it into here. Unfortunately, on my own old design, I wasn't able to get the magnet out, so I'm just going to use this piece that has the magnet already press fit. Push this in so the holes line up. Use a countersink screw. Use 2 countersink screws to attach the parts together. And do the same for the other side. So getting that to line up was kind of hard, but now you can see that the wheel is nicely attached to the motor. Do the same for the other side. Okay, so I did the same with the other side. So now we have 2 motors ready to go. Now let's match it onto the plate. Essentially, although it's hard to see, this plate's actually a little curved. And you can tell if you put it on a table, you can see I can squeeze it down a little. So you're going to want the curve to be such that If you do it like this, for example, the edges will be off the table. But if you do it like this, the center will be off the table. You want it such that when the center is off the table, the top side is going to be the top of the vehicle, which means that essentially the motors are going to go on like this, and this side is slightly higher than these sides. And what that does is that makes sure that nothing will rub the ground because the tolerances from the ground are pretty tight. Now that we've got that in place, I'm just going to put in a screw here and a screw there. So now you can see that it's well mounted, and there should be some tolerance built into the design on both sides. Let's do the same for the other side. Finally, take the laser pointer, put it into this measuring point, mount. Make sure to leave the label pointing up. And for now, I'm going to put it on here, but you can use shims to adjust the angle of this such that it points directly at your aligning device. All right, so now you're going to put in the laser pointer and screw it in from the bottom. So now take a bearing, put it into the side that has the flange in it, where the flange of the bearing goes into the accompanying hole, like that. And then on the opposite side, you take the encoder such that the chip goes into this hole, like that. And you'll see that the connector will fit out of the top. So this is an encoder assembly. Now, you fit it in from the right, and it'll just snap on. And then you put 2 holes from the bottom into it. So that's one side done. As you can see, it's supported on both sides, and it should be pretty smooth. All right, now we have the front half with the encoders. All right, so now that we're done with the front assembly, let's move on to the rear assembly. So the way this works is essentially this palm, also known as Delrin ball, will ride on these really tiny ball bearings that essentially make it so that it has no friction. So the way this assembly works is you're going to need to grab one of these really tiny dowels and take it and put it into the bearing. I find that it's a little difficult, but you can do it pretty easily with your bare hands. Once it's on, it should look something like this. You take it and you can see there are places that this fit into the top holder. So just fit them in. I found that tweezers make it quite a bit easier to line everything up and to put the ball in. Once you line it up, you can use your nail to squeeze the dowel into the 3D printed piece. Now you should notice that the bearing slides super smoothly. Like I feel no friction on this whatsoever. But the dowel is held in place with a nice friction fit. If it doesn't slide super smoothly, try sanding something in the area or try to figure out what's rubbing, and it could possibly just be a print defect. Now I'm going to repeat the same process, but with the other 3 bearings. There's the second one, also feels really smooth. And there's the third one. You can see that all 3 of them are in. Now you just take the white palm ball. And you can see that it should roll around really smoothly within this and make a nice satisfying sound. This will fit such that the ball is held in by this chamfered shape over here. So just put it on like that, flip it over. There's one screw that goes here and one screw that goes here. And now you've got a Tektite ball caster. It feels super smooth. And I think it looks pretty nice too. Now, grab your 2 carbon rods and they'll fit into this bit right here. Then, grab an M3 screw, put it through a washer, which is not meant to be confused with a shim. And essentially, you position it so that it squeezes this washer down on top of the carbon rod. Like so. And now, this carbon rod is not going anywhere. I'm going to repeat that on the other side. Now you have a rear assembly. It slides super smoothly, and this will go on the back of your vehicle. Now let's join the 2 halves together. So grab the rear half, put this battery holder on it such that this goes up to the front edge. Essentially Screws are gonna go through here into this, and this will become a friction fit against the carbon rod. All right, now it's rock solid. You can move it around like that. Finally, let's put in the PCB. So essentially this piece comes from below. Now this thing, there's essentially these leads coming out the bottom that make it so you can't just put it directly on top. So I designed this little spacer that'll keep those from touching the carbon rods, which I learned from experience are conductive. And you just put 2 screws and that's it. All right, so now we get your PCB on. Let's wire everything up. This is the cable for the left motor. This is the port labeled M left. So let's just connect left motor to M left. This is the wire for the right motor. That port's labeled M right. So let's do that. This is the wire for the laser pointer. So let's put that in. Finally, let's plug in our encoders. So you'll have these wires, and unfortunately I desoldered them, but you will get them pre-soldered. And essentially this port is labeled ENC left, and this is the left encoder. So I'm going to plug that in. So now you have a fully built vehicle. Finally, you can grab your battery pack and just it's a tight fit, but you can just go like that. When you aim this laser, you might find out that it doesn't perfectly line up with the ground. So you can essentially add shims below these screws, between these screws and the laser pointer, such that it lines up perfectly. And these are included with the kit. And you've got a vehicle.